So as you could tell, for this function, we don't have a vertical shift. So we put none or 0. Amplitude, we have also no amplitude, so none. But remember, if you're graphing the sine function, your amplitude is going to be 1. For a phase, we do have a phase shift, so that would be pi over 8, and that would be going to the right. And we know that our period is 2 pi, and this is my b, so I need to divide that by 2. That means my period is going to be pi. That also means that my important values are going to be pi divided by 2, so divided by 4. So every pi over 4, we're going to get an important value. Since that pi over 2 is probably not the best numbers to have for this graph, I'm gonna take those away, and I'm gonna say that this right here is pi over 8. Since I have to, since I'm gonna make this graph go by pi over 8, each little piece is pi over 8. So this is pi over 8, 2 pi over 8, 3 pi over 8, 4, 5, 6, 7, 8, pi over 8, whatever, and so forth to the left. But we are getting a special value or important value every pi over 4. So that means that pi over 8 plus pi over 8 is equal to 2 pi over 8, which is a pi over 4. So every 2 pi, every 2 pi value that I have, so here's 1, 2, that's going to be a special value. 1, 2, another special value. So this is why I mark those as bigger parts. That's where my little values are, because all of this is going by pi over 8 just because of my phase shift. So that means since I start there on my phase shift, and this is like a sine function, that's my intercept. So this is what we have for our sine function. That means that every intercept is an asymptote. And every max and min is my actual function that I'm graphing. And that's what we get. Now to find our domain, we know that our domain is going to be x is one of the reals such that x cannot equal. And then we need to find our general equation for our domain. That means we need to use this piece right there. So I'm going to rewrite it, and I'm going to multiply that 2 inside, just so it makes it easier, a little bit less work that I have to do later on. So this would be multiply the 2, you get 2 pi over 8, which reduces to pi over 4. So I'm going to use that because that would be my inside part of my function if I had my frequency inside my parentheses. So I'm going to have 2x minus pi over 4. And we know that the general asymptote for a parent function would be at pi over n, not pi over n, pi times n. So we're going to add the pi over 4 to both sides. And we're going to get 2x. I suggest you get a common denominator, so that would be 4 pi n plus pi over 4. And then we are dividing by 2 or multiply both sides by a half. So that goes away, and we're going to get that x is equal to 4 pi n plus pi over 8. And just to make this a little bit nicer looking for a general form, we're going to have that x is equal to 4n plus 1. So I'm going to factor out the pi from the top, divided by 8. So that means that we are going to get a asymptote every 4n plus 1 divided by 4 times the pi, where n is an element of an integer. This is the general equation for an asymptote. And then that means also that our range is going to be y is an element of reals such that y is going to be less than or equal to our min value, which is -1. And y is going to be greater than or equal to our max value, which is +1. So for this function, we have none for vertical shift. We technically don't have an amplitude, so there's none there also, but because we're going to be graphing the cosine function, technically our amplitude is going to be 4. So 1, 2, 3, 4. So we go there and there. That's our amplitude. Phase shift, we do have a phase shift, so it's going to be negative pi over 4 to the left. And we have no frequency, so that means we're going to have 2 pi as our period. Our important values are going to be 2 pi divided by 4. So it's going to be every pi over 2. We know that our phase shift was at pi over 4, negative pi over 4, so that should be here because it's halfway between negative pi over 2. But we know that we have in every pi over 2, we have an important point. That basically is 2 boxes away. So we know that this is a secant function, which is the same thing as a cosine function. That means this one starts at a max because, let me do it a different color, starts at a max because it's a cosine function and it's positive. So every 2, we're going to have a important point. So this right here is a length of 2, so our intercept would be there. Then another length of 2 would be here. That's my min. Length another 2 here. Another length 2 max. And we continue that on the other side. So length of 2, length of 2, length of 2. And we have something that looks like this as my cosine function for this. And now we have that. We know that all our intercepts are going to be our asymptotes. And all our maxes and mins are going to be our actual function graph. Which that means right here, we're going to have something that looks like this. Something that looks like that. And so forth. So we need to find our domain for this function. We're going to have x is the limit of the reals such that x cannot equal. And we are going to figure out what our general function for our asymptote is using our phase shift / frequency if we have it. So we are going to go x plus pi over 4 is equal to, since this is the secant, we're going to have pi over 2 plus n pi as what we're going to equal. We're going to solve for our x. So I suggest that you get a common denominator for the right side just to make things a little bit easier. So that would be, I'm going to move the n to the front. So that would be 2n pi plus pi over 2. I'm going to subtract the pi over 4 from both sides. That goes away. I'm going to get x is equal to, now I'm going to get another common denominator. So I'm going to multiply top and bottom of this by 2. So that would be 4n plus 2 pi minus pi, all of that over 4. You're combining your like terms, you're going to get x is equal to 4n plus pi over 4. And we're going to simplify that, and I forgot a pi here and here. We're going to take the pi out, factor it out. So we're going to have 4n plus 1 times pi over 4. And that's going to be our general formula. So we're going to have 4n plus 1 divided by 4 times pi, where n is the element of the integers. That is our general formula for all of these asymptotes. Then we have our range. Y is on the reals, such that y is going to be less than or equal to my min value, which was -4. And y is going to be greater than or equal to my max value, which was 4. of my graph. And this is the domain and range.